Hello everyone, welcome back to the Red Team training series. In this video, we are going to be taking a look at privilege escalation on Windows. So again, we're focused on the privilege escalation tactic now, and we are going to be again taking a look at various techniques that you can utilize to elevate your privileges on Windows systems, given that this series was targeted towards Windows systems. So in regards to what we will be covering exactly, we'll start out by taking a look at the techniques, the privilege escalation techniques that we will be exploring. We'll then take a look at at each individual techniques within the practical section of this video. So we'll start off by bypassing user access control to elevate our privileges. We'll talk about kernel exploits and impersonation attacks. And the reason why I'm covering these techniques as opposed to any others is primarily because these will provide you with the best chance of actually elevating your privileges, or these particular techniques have been known to work as opposed to fail based on various environments or based on tests that have been performed in various environments. So again, these are pretty much the ones that I think are very important to begin with before you start exploring the process of exploiting Windows services in order to elevate privileges. And I'll probably make a video covering that. That being said, let's explore these techniques a little bit in depth. All right. So when we talk about bypassing user access control, these are the descriptions that I got from the MITRE website. And the reason I'm using them is just to have an accurate picture of what exactly these techniques entail. So when we talk about bypassing user access control, adversaries bypass UAC mechanisms to elevate processes or process privileges on a system. All right, so the user access control feature on Windows allows a program to elevate its privileges. And of course, this is facilitated by the tracking of processes and their integrity ranging from low to high in order to perform a task under a administrator level permissions, possibly by prompting the user for confirmation. So again, as I said before, when we actually covered bypassing user access control with Empire, I mentioned basically how it works. And as I said before, what we're trying to do is essentially utilizing UAC mechanisms to elevate the process privileges on a system. All right, so when we talk about kernel exploits is essentially when you identify vulnerabilities within the Windows kernel for that particular target, and then of course you exploit those vulnerabilities in order to elevate your privileges, right? And of course the description gives you an idea of what's going on here. So adversaries may exploit software vulnerabilities in an attempt to elevate privileges. Now, the description from the MITRE website is also referring to applications or third-party solutions that may have vulnerabilities within them that could provide you with elevated privileges. However, in this case, we are going to be focusing on kernel exploits primarily because, again, they will actually provide us with the best chance of actually elevating our privileges. You then have token impersonation. Token impersonation is a fairly simple technique to understand. And I'll just go through the description really quickly. So adversaries may duplicate, then impersonate another user's token to elevate the privileges and bypass access controls. An adversary can create a new access token that duplicates an existing token using duplicate token. The token can then be used to can then be actually utilized using the impersonate logged on user privilege to allow the calling thread to impersonate a logged on user security context. All right, so what's happening here is we're essentially finding impersonation or delegation tokens that we can utilize and then impersonating them in order to obtain their privileges. So for example, if we find an anti-authority system token, we can impersonate that token to obtain its permissions. And of course, its permissions again are essentially root or administrative privileges. So again, we're able to obtain administrative privileges, or we've been able to elevate our privileges, right? So these are the three techniques that we'll be looking at. And of course, you can take a look at the MITRE attack privilege escalation tactic on the website. And you can see I've highlighted these techniques that we'll be covering. So abusing elevation control mechanism, access token manipulation, exploitation for privilege escalation, etc., etc. And of course, I will be covering additional techniques within this particular tactic in the future. That being said, let's take a look at our target environment, or the environment we'll be using to essentially perform our privilege escalation techniques. So we'll start off with a Windows 10 virtual machine, or the Windows 10 target, Windows 7 and also Windows Server 2008 R2. So again, the reason I'm doing this is to give you a feel for how various versions of Windows operate in regards to particular techniques and what techniques work best on each of them. And again, we'll go through this dynamically. All right, so that's pretty much it in regards to the theoretical aspect of this video. Now that we have all of that out of the way, let's actually get started with the practical aspect of this video. So I'll see you back on my Kali VM. All right, so I'm back on my Kali VM, and the first technique that we're going to utilize is bypassing user access control. And I'm again going to be doing this on my Windows 10 target. And I have already received a ping back from the Windows 10 target on Empire. This is Starkiller, so you can see Windows 10. And again, I can interact with it. However, if you actually notice the our privileges, we can see that this is not a high integrity agent. And that means that we don't have administrative privileges. So that is going to be the goal. And we'll do that by utilizing the bypass user access control module. And we'll also replicate the techniques with Metasploit so that I can show you how it's done manually. So again, I've also retrieved a Meterpreter session on the Windows 10 target system. So again, if I just type in sysinfo, you should be able to see that we are running on the Windows 10 system. So I'm just going to wait for that to load. There we are. We can see Windows 10, and our objectives now is again to elevate our privileges to NT authority system or to the administrative level. Right, so that is going to be our objective. So we'll start off with Starkiller, or Empire, if you will. So again, as I mentioned before, if you click on an agent here, and you can also do this through the Empire client. If I click on View, again, you can try and enumerate whether this is a high integrity agent or not, and I'll just do this through the Empire client here. So again, I'll just list out my agents here, and I'll say interact, and I'll specify Windows 10. And if I display the info here, you can see under high integrity, the value is set to 0, which means we don't have admin privileges here. So the module that we're going to be using, so I'll click on interact, we'll be using an Empire module, and the module is going to be bypass UAC, right? And we're looking for the PowerShell Privesc bypass UAC module. So I'm going to click on that. We need to provide a reverse listener so that we can actually get our high integrity agent, because it is going to execute, and then we're going to get a new agent on the same target with elevated privileges. So I'll specify my listener as HTTP. We'll just use that. You can provide any obfuscation methods here based on the actual type of obfuscation you want to perform. As I've already mentioned before, we've covered defense evasion, and again, you can apply those same techniques, but in this case, it is already going to be assumed that you have access to the target and you've evaded antiviruses or any antivirus system in place. That being said, that's pretty much all that we need to provide here. So I'm going to submit that. And you can see it's going to say module execution queued for Windows 10. We can then click on the agent here and view the running tasks. So I'm just going to load this here, and let's see whether we'll actually get a callback or we'll actually get a high integrity agent that actually connects back. Alternatively, you can also use the Empire client here in the terminal, and again, I'll just say agents, and then I can say interact Windows 10, and again, I can also display the history of commands that we executed here. So again, I'm just going to wait for this to execute successfully. All right, so it looks like the module actually executed successfully, and again, we get back our high integrity agent. And again, I can hover over it, and you can see that this is an elevated process. So I can click on that, and I'm just going to rename this to Win10 Priv, or we can just say high integrity. And again, I'm just going to get rid of the hyphen there, Win10 high. Again, just to keep things nice and simple, so that we actually have an understanding of what system we're dealing with. You can see that that is now privileged, and we've been able to successfully elevate our privileges to the highest level with Empire. Now let's take a look at how to replicate the same privilege escalation technique using Meterpreter or manually. So again, this will work if you have a Meterpreter session on the target, which I'm guessing you do. And the first thing, again, we want to do is just verify our privileges, which you can see here are standard. What I'll do now is I'll just put this in the background. And I will then, of course, list out my sessions. You can see the session ID is set to 1 here. And again, you can actually get information regarding this particular Meterpreter session here. The first thing I want to do ideally is to actually migrate this particular interpreter session, or the process rather. So again, I'll just list out the processes on the target system, and I'll migrate this to explorer.exe. So that's under PID 4040. You can see it there. So I'm going to say migrate 4040, hit enter. That's going to migrate me to a 64-bit interpreter session, which is actually quite useful when running post-exploitation modules with Metasploit. You can see migration completed successfully. I'm then going to say sysinfo. You can see we're running now on a 64-bit interpreter session. So I'm just going to put this in the background now. And we want to search for bypass UAC. And there are going to be multiple modules based on the actual exploitation technique and the various Windows components that you're going to be targeting. So in this particular case, you can see that we have, as I said, multiple ones. This particular module will again is just a standard Windows Escalate UAC protection bypass. You can also do it in memory, which is what I recommend, primarily because number one, you'll evade any antiviruses if there are any antivirus systems in place. And secondly, you never ever want to interact with the Windows service, like for example, the event viewer, unless you know how to clean up your mess. So we'll use the exploit Windows local bypass UAC injection win SXS, as that works really well on Windows 10 systems. So I'll use that module there, and I'm going to set the correct payload for the target operating system architecture. So I'll set the payload to Windows x64 interpreter reverse TCP, right? And we can then also show the various options here. You can see that the exploit target is set to Windows x86. So I'm going to say set target, if I can set it here, set target to Windows x64, because the target is 64-bit operating system. We then want to set the L host and the L port and the session. In my case, I'll leave the L host and the L port there. I'll set the session to session 1, and then I just hit run. And let's see whether we're able to, again, elevate our privileges successfully. All right, so we get a interpreter session here. And again, we can type in get UID. You can see we're still MS Edge Win 10 IE user. So we're currently the IE user, which again is not privileged. However, we can actually check what privileges we have by typing in get privs. So again, I'll just type in get privs there, hit enter, and you can see we have the all the privileges associated with an administrator account, right? And one of the key ones that we'll be exploring later is the SE impersonate privilege, which again is used to impersonate Windows access tokens. So we'll actually take a look at that technique. That being said, you can actually see that we have been able to elevate our privileges successfully. And this was how to elevate your privileges using by bypassing user access control on Windows 10. So let's move on to the next technique, which will be again utilizing kernel exploits. So I'll see you once I've set up the target system. All right, so the next technique we're going to be taking a look at is kernel exploits, right? And our target system is going to be a Windows 7 system. You can check out the system information here. I've already obtained an initial foothold on the target system. And the first order of the day is to actually migrate our process into a 64-bit process so that we can obtain a 64-bit interpreter session. So similarly, we'll just print out the process tree here. And again, we'll look for Explorer, as it provides us with the best option in terms of a stable process to migrate to, as the Explorer will never be forced to shut down or restart normally under normal use cases. So we'll say migrate. And then explorer.exe is 1864, that's the process ID. So 1864, hit enter. We're going to migrate to that process. And then of course, I'll try and print out the system information. And let's see whether that is successful. So sysinfo. And you can see we're on 64-bit interpreter session. All right, now this particular technique is I'm going to handle it in a manual way. Again, we're not going to be using Empire primarily because we can't perform kernel exploitation with Empire. We can only do it using a manual command shell. And we're not going to be using any tools or utilities that we will be transferring over to the target system apart from the kernel exploit itself. So the first part of privilege escalation is to perform local enumeration of the target system. And of course, in the context of kernel exploitation, the information that's important to us is the operating system version, the build number, the service pack, and the architecture, as well as the updates or hotfixes that have been installed on the target system. So if I just spawn up a shell session here, and let's see if we actually get a shell session. There we are. So I'm just going to type in system info, and this is a native Windows command. I'll hit enter. This command will display all relevant information pertinent to this particular operating system or the target, right? And if we take a look from the beginning of the results, we can see that it's Windows 7 Ultimate. The OS version is 7601, Service Pack 1 build 7601. The other information that is useful in this case is going to be the hotfixes installed, and it's going to provide you with the hotfix IDs that again will either tell you what exploits, kernel exploits will work, or what kernel exploits won't work based on what has been patched and what hasn't been patched. So the process of identifying kernel exploits can be done manually or automatically through the use of a tool called Windows Exploit Suggester. And again, the link to this GitHub repository will be in the description of this video or in the documentation of this video. And all you need to do is clone the repository, and it's a Python script. And the way it works is fairly simple. It's a tool that you run on your Kali VM, not on the target. So you can see it's a Python script that you actually execute, and it is a Python 2 script. So again, it's vital that you install all the dependencies right over here, as you can see. And it does come with a requirements file, or you can essentially install the dependencies manually by following the instructions here. And again, the first thing you need to do is just run the tool to obtain an initial database, a vulnerability database. And what this database is essentially a list of all Windows exploits or vulnerabilities. And again, the next piece of information that you need to obtain is this information right here. So you actually need to copy out the output of the system info command from the target system. So I'll just copy it right over here, and you need to paste it into a file. So I'm just going to open up my text editor. I'm then going to paste this into a file, and I'll save it on my desktop here. And I'll just call it, let's see, we'll just call it Windows 7, Windows7.txt, right? And I'll hit save, and there we are. That's going to save it. And now we can run the tool on Kali, the simple or Windows Exploit Suggester rather. Let me just stop serving that. And I'll just head over onto my desktop where I've cloned the repository. So this is under Windows enum and Windows Exploit Suggester. There we are. That's the tool. And you can see we have the script here. All right. So now in terms of running the tool, as I said, we need to run the tool with Python and then provide the database file that you can get by running the update command. And then you provide the system info information that you just copied and pasted into a TXT file. And then you hit enter, and it's going to utilize the system information file and cross-check with the vulnerability database to identify any potential vulnerabilities that we can exploit. And in our case, we're looking for kernel vulnerabilities that will elevate our privileges, right? So we will run this, and I'm just going to run it here. So we'll say Windows Exploit Suggester. I already have my database, and it's quite up to date. And then I'm going to specify my database option. So I'll say database, and then I specify the file. So it's there's the database file, and then we have to provide the system info command, and then we provide the file containing the actual system information we just copied over. In our case, it is on my desktop, and it is called Windows7.txt. We're going to hit enter. And we want to give that a few seconds to generate or to display all the vulnerabilities that affect this particular version of Windows. And I just want to highlight one thing is that when you have the output of this particular tool is color coded, in that when you have a green output, that means that again, it's a positive result for a vulnerability. And again, in this case, the vulnerability is outputted in terms of their vulnerability code, the Windows or Microsoft vulnerability code there. It also provides you with exploit links to the exploit code and a reference link that will actually tell you more about what this particular exploit does or what it's exploiting particularly, right? So let's try and identify one here that again will provide us with privileges or will actually elevate our privileges, right? And right over here, I can identify one that again looks quite interesting and might be able to help us. You can see security update for secondary logon to address elevation of privilege, and it provides us with exploit code. And it looks like there are few versions of the exploit code based on the target operating system. So we can see that we have Windows 7 to 10 and Server 2008 to 2012, both architectures 32-bit and 64-bit. But let's see if we can find any more information regarding this particular vulnerability. All right, so let's actually see what we can find. So what we can do is just copy that particular vulnerability code here, and we can use Google or some Google Docs. So I'll just open up Google here. There we are. And we'll just paste that in there. And then we'll limit the output to exploitdb, or to only show results from exploitdb.com. And again, we can see what this particular exploit does. So we'll click on the first link here, as that's pertinent to our version of Windows. So let's see what it does. You can see that this is the PowerShell implementation of MS16032. The exploit targets all vulnerable operating systems that support PowerShell version 2. And again, the way it works, you can see that it requires 2 or more CPUs to work. And you can learn more about this particular exploit by clicking on the reference link. And this write-up was done by the Google Project Zero security team. So I'll just open that up and let's see what this particular exploit pertains to, or what it's actually exploiting. So it looks like it's exploiting the secondary logon handle. And it says right over here, once in a while you'll find a bug that allows you to leak a handle opened in a privileged process into a lower privileged process. I found just such a bug in the secondary logon service on Windows, which was fixed this month as MS16032. The bug allowed you to leak a thread handle with full access. All right, so that gives you a bit of a description. You can go through the entire write-up as to how that is done. We can also take a look at a few other exploits that were actually displayed here. And again, through my usage of this tool, the best options or the best exploits that again have the highest chance of success are going to be the ones at the top here. So for example, MS16135 actually looks like this is a security update for Windows kernel mode drivers, and this is a kernel exploit as opposed to this particular one here. Let me just open that up. So this particular exploit isn't a kernel exploit. This is essentially exploiting the secondary logon handle. So again, what we can do is I'm just going to reopen that tab and we'll head back over to Google, and let's see whether we can gather more information regarding this vulnerability, as it directly targets the kernel. And you can see this particular exploit code provides us or performs privilege escalation, or will provide us with elevated privileges. Right, so what we can do is go back, and I'm just going to remove that particular exploit or vulnerability code there, and let's see what this one pertains to. So we can again see that it provides us with the source or a reference link, the binary link. These are going to be the compiled binaries, and a mirror to that particular executable that we can utilize. And again, we can also learn more about what's happening here, but let's actually try out this particular exploit. So when it comes down to downloading exploits, I recommend utilizing exploitdb, and of course I also recommend compiling the code yourself into an executable or a binary instead of downloading pre-built binaries. The reason I'm saying this is because pre-built binaries may have malicious code unless they're coming from a trusted source like Offensive Security right over here. Now, I also want to make one thing clear. Whenever you're targeting the Windows kernel, you're essentially playing around or mucking about with the core of the Windows operating system. And of course, the Windows kernel is Windows NT. That means that if you make a mistake or there's an issue with your code and you execute your exploit code, you may actually cause the operating system to crash, right? Which can cause data loss. Again, it can raise certain alarms, so on and so forth. So you have to be really careful about what you're executing on the target, and you should again perform research on the kernel exploits that you're utilizing. Now in this case, I've already used this before, and I know that it doesn't cause any issues, and I'm familiar with the source code. I've compiled the binaries many times, so I can almost guarantee that if you run this particular exploit on a Windows 7 target, you'll not have any issues in regards to stability of the target system, right? So what we're going to do is, if we go back into Kali here, And you can see that it provides us with the exploit code. So we can actually download the code from exploit.db, or the pre-built binary as it were. And we can then transfer it over to the target. But before we do that, we also need to learn about how this works, right? So what I'll do is we can just take a step back here, and we can just open that up in a new tab, and we'll say MS16135 exploit, right? And let's see whether we get any links. All right, so it looks like we get a link to a GitHub repository here. And if we click on the actual the actual exploit or vulnerability code there, you can see that it provides us with pre-built binary. That's going to be the executable here, and the C code that you can actually compile yourself, right? So I will be covering how to compile Windows exploits in the future. This is beyond the scope of this video, but you also have the PowerShell scripts. So it looks like this will work on all 64-bit vulnerable targets. You can execute it with PowerShell, or you can also use the executable. And the way you utilize this exploit, and I'll just show you how it works, is you need to run the target executable on the target, or the exploit binary on the target, and then provide the version of Windows that you're trying to exploit. So if it's Windows 7, you exploit it and provide the 7 option. If it's 10, so on and so forth. So it's fairly simple to understand. So we can actually download this from the GitHub repository, or we can utilize the official source here, which is again going to be from Offensive Security Exploit DB. But in our case, we'll just download it from here, as I know that this is a trusted source. So I'll just click on it here. We can then say download, and I will save it in my downloads directory. And now what I will do is I'm just going to move it from my downloads directory, or we can actually leave it within the downloads directory. I'll just change my directory into the downloads folder, and we can see it there. So I can now, we now need to transfer it over to the target. Now, given that we're utilizing manual techniques, there are 2 ways we can go about doing this. One of them is by uploading it using Meterpreter. So if I head back over into my Meterpreter session, I can utilize the upload functionality, and then specify the exploit that I want to upload in the directory that I want to upload it in, and then execute it that way. Alternatively, I can also utilize the certutil utility to transfer files. So I'll actually take you through both. I'll take you through the manual process. However, there is one thing that we're missing out. Remember, we currently are an unprivileged user, right? So if I say, get user ID here, you can see that we're currently the user, where our user name is simply called user. So we need to, again, if I list out my current working directory, we're in the system32 directory. So we need to head back over to the root of the C drive, and then users. There we are, users, and we'll then hit enter, and then cd user. And we can then save the files here, as this particular user will have the necessary privileges to save files to this particular user directory. So we will save them in our downloads folder. Of course, whenever you're transferring exploit code onto the target, you want to do this in a folder that is not frequently accessed by users on the target system, and so that your payloads are not detected. Another way of actually going about doing this is by going to the root of the C drive and taking a look at the temp directory. So the temp directory, again, is where you can store all your temporary files. And again, it's a folder that's not frequently accessed by users on a target system. So I'll just head over into the temp directory, and we can now transfer the exploit over onto the target. Now, in order to transfer it over to the exploit or to the target, we need to set up a web server that will host that exploit code for us, and we can do that on Kali using the simple HTTP server module. That's a Python module that again allows us to set up an HTTP server in the directory that we're currently working in. So in this case, we're in the downloads directory, and you can see it has the exploit here. We'll just rename the exploit to something that's more identifiable. We'll just call it exploit.exe. Now, again, I don't recommend doing that or giving applications names like exploits, as that can again raise alarms. So I'll just move it. In this case, we're just doing it so that we can easily identify it. So I'll say sudo python m simple HTTP server, and we'll run this on port 80. So this is going to set up our web server within the downloads directory. And then on the target system, we can open up a shell session. And I will then, we are currently within the temp directory. So if we list out the contents of the temp directory, I have the shell that I was utilizing or that I actually utilize to gain access here. So again, what I can do, let me just head over into Meterpreter. Let me just remove shell.exe. Let me just make sure that that is out of there, and I'll then open up a shell here, and there we are. List the contents there. We don't have anything, so now we'll utilize certutil to download the file from our Kali web server. So we'll say certutil, and then we'll say URL cache, and then we'll specify that we want to download it from the following IP address. This is going to be your Kali IP, and the name of the file is exploit.exe. We then need to provide the output file name, which is going to be just exploit.exe. Hit enter. It's going to download that from the target. Let's see whether the file is there. We can see we have exploit.exe. So now we can try and run the code. So I'm just going to say exploit.exe. And you can see that it provides you with instructions as to how to run this particular kernel exploit. And in our case, our target is running Windows 7. So we simply need to run the executable and provide the option 7, as it says here. So we will do that. We'll do exactly that. So I'm going to say exploit.exe and 7. And again, given the fact that I have experience with this particular exploit, this exploit will take a few seconds to work. So again, you want to give it probably around 10 to 30 seconds. So I'm just going to hit enter, and again, just give it a few seconds to execute. All right, so once it executes successfully, we can then again enumerate our permissions by simply typing in who am I. So if I type in who am I, you can see NT authority system, and we've successfully been able to elevate our privileges. So I can head back into my Meterpreter session, and if I say sysinfo and I say, get user ID, you can see it's still going to say we're the current user, but we have NT authority privileges there. And yeah, we've been able to successfully elevate our privileges through a kernel exploit on a Windows 7 target system. So that is how to perform manual kernel exploitation, or how to utilize kernel exploits manually. As I said, I've not utilized any Metasploit modules. There are modules that exist that can be utilized to exploit the kernel. However, as I said, I'm not going to be covering that because it's essential to know how to transfer exploits manually over to the target system, how to execute them, and of course, verify that we have elevated our privileges. So that's going to be it in regards to using kernel exploits to elevate your privileges. The next technique we're going to be taking a look at is token impersonation. So I'll see you when I have the target set up. All right, so we are now going to be taking a look at token impersonation, and we're going to be focusing on the process of utilizing impersonation attacks in order to elevate our privileges. Right now, I'm going to be using a Windows 7 system, however, under different parameters, and you'll understand why in a few seconds. So you can see it's a Windows 7 target, build 7601, service pack 1, and we're using a different user called Windows 7, right? And let me just give you a brief explanation of what token impersonation attacks entail in relation to privilege escalation, right? So token impersonation attacks leverage specific Windows privileges, such as the SE impersonate privilege, in order to obtain an access token with administrative privileges that we can then impersonate in order to elevate our privileges. So if that's a bit confusing, let me explain what Windows privileges I'm referring to. So for example, if I type in get privs, and of course this is going to get the privileges for this particular user, you can see that it'll list out all the Windows privileges associated to this user, and these privileges essentially classify or identify what this user can do. And if you take a look at a very interesting privilege here called SE impersonate privilege, that is the privilege that we're going to try and exploit in order to impersonate an access token that of course has administrative privileges. In this case, we're going to try and impersonate the NT authority system access token. Now the question is, how exactly do we get those impersonation tokens? That's the key thing here that you need to take away from all of this, right? Now there are multiple techniques that we'll be utilizing, and this will depend on the version of Windows you are targeting. And in this case, we'll be taking a look at potato attacks, more specifically the rotten potato attack. However, I'm just going to give you a basic overview of how this works. Before I do that, however, if we take a look at If we take a look at the vulnerabilities that we were able to enumerate for the Windows 7 target, and let me just try and identify the actual vulnerability that I was talking about, or that I actually want to highlight here, that has to do with a particular potato attack. Hopefully I can find it here, so it's not too difficult. Let's see. We're looking for the potato attack. Right, there it is. I think I can actually see it now. So there we are. That's MS16075 security update for Windows SMB server, right? And you can see it actually provides a description. So this is hot potato Windows privilege escalation, and you can learn more by actually utilizing this particular write-up, and it's a very good write-up. It actually explains what's going on, right? And it is quite a sophisticated attack in the sense that in order to obtain the privileged the privileged access token, there needs to be a few things done. So you can see that the potato attack works by taking advantage of known issues in Windows to gain local privilege escalation in default configurations, namely utilizing the NTLM relay, specifically the HTTP SMB relay and NBNS spoofing. So again, just to simplify what's going on here, what we're trying to do is we're trying to exploit a vulnerability within Windows, and we're getting a process. And in this case, let me just see if I can find that step, because that's very important here. There we are. So the fake WPAD proxy server in Windows Internet Explorer by default will automatically try to detect network proxy setting configuration by accessing the following URL. This also surprisingly applies to some Windows services such as Windows Update, right? And the URL does not exist on the fake proxy server that we'll set up, or that this exploit sets up. So what will happen is with NBNS spoofing, we can target our NBNS spoofer at localhost. We can then flood the target machine with our own NBNS response packets and essentially get the privileged access token to actually be sent to our fake WPAD proxy server here, right? So what's happening is fairly simple. We're essentially intercepting the privileged access token, and again, once we obtain it, we can then utilize it to impersonate that particular access token. So that's a very simplistic explanation of what is going on here. If you want to learn more about this, I'll probably make a video that explains each step of what's going on. And as I said, it's a fairly complicated exploitation process. But luckily for us, Windows or Meterpreter actually has, or Metasploit rather, actually has a pre-built module that allows us to exploit this very vulnerability, right? And obtain our impersonation token, right? Or retrieve our privileged access token that we can impersonate. So we will also be utilizing a module that's inbuilt into Meterpreter called incognito. So if I say load incognito, and then I list the tokens right here for all the users, you can see that we currently have delegation tokens that we can utilize, like the anti-authority system token here, but that is from a previous exploitation that I had performed. But I'll still take you through the process of retrieving the this particular access token, because right now we can essentially impersonate that token by typing in impersonate token and then providing the token that we want to impersonate. But I'll take you through the process of running the module first. So I'll just put this in the background, and we can then search for MS16075, right? We hit enter, and we have the module for that particular vulnerability, and it's going to exploit it. So you can see Windows Net NTLM v2 reflection, and we just copy it, and I'm going to paste it in there. And we need to set the correct payload. So payload Windows x64 Meterpreter reverse TCP, right? And we show the options here. We need to set the session. So let me just list out my sessions here. So set session 2. There we are. And I'll leave the L host and the L port options as are, because I don't need to actually change the L port here because I don't have anything running. So I'll just hit run, and let's see. All right, so it's going to run the exploit, and it's going to give us a new Meterpreter session. If I say get UID now, you can see it's still going to say Win7 PC Win7. And if I say get privs, it's going to give us the same privileges that we had before. If If I open up a shell session and I say, who am I? It's the same thing. So you might be asking yourself, well, that didn't work. What's going on here? Why don't I have administrative privileges? Well, that's because what this exploit does is actually provides us with the impersonation token. So if I now say list tokens, sorry, we haven't loaded incognito here, but let me just say load incognito and then list tokens. You can now see that we'll have the NT authority system token here that we can impersonate, right? So again, this is a delegation token, but we can use it the same way. So I'll say impersonate token and I'll paste that in there. And there it's going to say successfully impersonated user token. And if I say get UID, we now have NT authority system privileges here, and we've been able to successfully elevate our privileges. Now, as I said, this exploit can be performed manually by, of course, taking a look at potato attacks, more specifically rotten potato. So, for example, I'll just search for it here, rotten potato, and I'll click on the first link here. This is the best vector or exploit that you can actually utilize. So you can see local privilege escalation from Windows service accounts to system. So the usage for this exploit is simple. You compile it, you get a interpreter shell on the target system, you load incognito, you run the binary, and then you impersonate NT authority system, right? So again, they already have the pre-built binary here, and I think I can actually take you through the process by utilizing a non-privileged session. But again, you do require the SE impersonate privilege, otherwise you will not be able to impersonate any access tokens that you are able to retrieve. So let me just explain a little bit about rotten potato attacks, because they are slightly different, and of course this is going to be much more manual. If we take a look at I already have the exploit code, I believe, on my Kali VM. You can actually take a look at the source and compile it yourself, but we'll be utilizing the pre-built binaries here. And we need to transfer it onto the target, and then what we need to do is essentially run it, and we should be able to retrieve a system access token or NT authority system access token and then impersonate it. So what I'll do is let me just put this in the background, right? And we'll head over into our unprivileged session. So sessions 2, right? And what's my current working directory? I'll head over into the C drive, and we'll head over into temp, right? And within here we had the earlier kernel exploit that we utilized, no problem there. If I check out my, let me just clear that out. If I head over into my desktop, Windows exploits, and within this here we should have the potato folder. There we are, and we have the rotten potato exe. So I'll again utilize the simple HTTP server. So simple HTTP server. And I'll host this on port 80, and now we can transfer it using cert util. So I'll just open up shell here, and we'll say cert util URL cache, and then we specify the Kali IP here, 192.168.2.21, and this is rotten potato.exe, right? And we'll save it as potato.exe just to keep the name shorter. And we'll hit enter, and we'll wait for that to transfer, and it looks like it transferred successfully. So now in terms of running the exploit, all you need to do is simply run potato.exe. We hit enter, give that a few seconds. It's going to start the relay, and it's going to say, it's going to start the relay, and then it's going to receive the challenge, the NTLM authentication challenge. And with that NTLM authentication challenge, you get the access token, and then it's going to say right over here, got type 3 message auth token relay, you are now system decom connection terminated, and let's see whether we actually got anything here. So I'm just going to wait for it to complete, and let's see whether we were able to get NT authority system privileges. All right, so it completed running, and now if I list out the tokens, you can see that again it'll still display the same things, but we have the NT authority system token here, and we can then impersonate it. So again, I'll just say impersonate. There we are. Let's see if it successfully is able to impersonate the user NT authority system. There we are. If we type in a shell, and who am I, anti-authority system, and that is how to perform potato attacks manually and automatically using a Metasploit module. And of course, we've been able to elevate our privileges successfully. So that is in general how to again perform token impersonation attacks on Windows. So that's pretty much all that I wanted to cover in this video. As I've mentioned within the slides, there are many other techniques that you can utilize, but these are the techniques that are the most stable across board. And again, you will have to change your approach based on the version of Windows you're targeting. As I said, with Windows 10, it's very difficult to actually find vulnerabilities that again can allow you to obtain access tokens like this, but it's not impossible. And you can try out the other techniques listed out under the privilege escalation tactic on the MITRE ATT&CK website. That being said, that's going to be it for this video, and I'll be seeing you in the next video.